Hello, and thank you for joining today's Environment and Energy Leader webinar titled Ethylene Oxide, the Changing Legal Landscape and Challenges of Compliance, sponsored by Montrose Environmental Group. My name is Jessica Hunt, and I'm the Director of Live Events for E&E Leader. We appreciate everyone joining us live, and a large thank you in advance to those who will be watching this on demand. I apologize in advance if you hear my son or either of my dogs during today's webinar. Before I hand the presentation over to our speakers, I do want to go over a few housekeeping items. If you experience technical difficulties during the event, please follow the troubleshooting tips located in the Help widget at the bottom of your console. If you are still having issues after following the steps, please send a message to me via the Q&A widget, which is open on the top right part of your screen. We will be holding a Q&A session at the conclusion of the webinar. So if you have questions, please submit over the next 45 minutes. If we do not get a chance to answer your question during the live event, one of the speakers or a member of their team will follow up with you as soon as possible. If you are watching this presentation on demand, please feel free to submit questions, as all questions post-live events will be forwarded to the appropriate teams. We have three wonderful speakers who will be presenting this afternoon. I would like to welcome David and Pilar from Montrose Environmental, and they will be joined by David Nunn from Eastman Smith. You can read more about their background and expertise by clicking the arrow below their headshot. And at this time, I am going to turn the presentation over to Pilar, and I will rejoin you for the Q&A. Pilar, the mic is all yours.
Thank you, Jessica. Good afternoon, everyone. Thank you for joining us today. By now, you have all probably heard about ethylene oxide and have a general idea of what it is, but I will give you a brief introduction as it pertains to our presentation today. Ethylene oxide is a flammable gas, and it's used for the production of certain chemicals like detergents and adhesives. It is also used to sterilize equipment and plastic devices that cannot be sterilized with steam, like medical equipment. And ethylene oxide in the air can come from different sources, so industrial sources, so the chemical manufacturers and sterilizing facilities. But it's important to know that it can also come from other non-industrial sources like vehicle exhaust or plants and cigarette smoke. The US EPA classifies ethylene oxide as a known human carcinogen, and there are federal emission standards that restrict emissions from some sources. In 2016, the EPA actually updated the carcinogenic risk for ethylene oxide and determined it to be more carcinogenic than they originally thought. So then in 2018, they updated the National Air Toxics Assessment, which identified different census tracts across the U.S. that had elevated cancer risk due to ethylene oxide emissions. And I should note that there are some organizations and even agencies like in Texas, CCQ, that have raised some concerns over the assessment and believe them to be flawed. Texas has even come up with their own cancer risk evaluations. And we're going to mention this National Air Toxics Assessment report quite a bit during this presentation. So I kind of wanted to give you an idea of what that looks like. If you go to EPA's website, you can find a map of the U.S. and you can zoom in to different areas with increased cancer risk. And you can identify what chemicals are contributing to this cancer risk. And you can even see what facilities are located within that area and even what emissions these facilities have. The EPA got this emissions information from data that you may have provided for the National Emissions Inventory and Toxic Release Inventory reports. And now I'll hand it over to David, who will go over the history and current regulation of ethylene oxide.
Excuse me. Thank you, Pilar. Yes, my name is David Nunn. I'm an Ohio-based attorney, and I would call myself a generalist in the environmental world. And my entree into ethylene oxide was through a national healthcare distributor who, of course, is distributing many sterilized products throughout the country in many states. And let me just flip. Okay. I would say this as a starting comment about ethylene oxide. If it had the impacts that some of the other toxic chemicals have to both soil and groundwater, in addition to air, it would be a huge issue, much bigger than it is now. Similarly, if it affected more manufacturing sectors than just the chemical manufacturing base and sterilization industry, it would be a huge issue. And I say that because of the actual effects that we're going to talk about today in terms of how much the regulations change the landscape for what's acceptable exposure and what is not. Basically, from a historic perspective, ethylene oxide was identified as a hazardous air pollutant in 1990. It had a NESHAP adopted in 1994. And I am speaking only in terms of the sterilization side. I'm not speaking in terms of the chemical manufacturing side. There are NESHAPs for those sectors as well. But on the sterilization side, sterilizing facilities essentially have to capture and destroy 99% of the ethylene oxide emitted during the sterilization process in their sterilization chambers. And they do that through thermal oxidation. And frankly, I think it's a fairly straightforward capture and control process that everyone got pretty comfortable that they could meet and do. And so the only really other regulations from a federal level that came into play with ethylene oxide for the first several decades would be your toxic release inventory reporting, where you do have to use your best engineering judgment to try and determine the routes of releases of ethylene oxide from your facility and then report that if you are a reporting facility. There are also certainly other ancillary regulations, FIFRA and Food and Drug Administration regulations as well. I'm not going to get into all the specifics of the original NESHAP. I'm sure many of you are familiar with them, and the second slide here does run through some of them. But as I say, it really is a best available technology kind of an approach. And, I think most sterilizers were able to adapt to it and meet the requirements, with the exception perhaps of accidental releases. So again, as I kind of mentioned, for the first several decades, it was really a fairly non-controversial chemical. There was after the adoption of the NESHAP, there was the risk review was undertaken, and in 2006 they found no need to revise the rules, and that stayed in place for almost another decade. Again, actually it was another decade until EPA's IRIS group completed their risk studies and reevaluated the carcinogenic potential of ethylene oxide. And in the process of doing that, they issued a new unit risk factor that was substantially lower or produced higher risk, let's put it that way, than the original evaluation. And it also, as Pilar mentioned, changed the designation from probable human carcinogen to known human carcinogen. And at the same time, and again, as Pilar mentioned, the National Air Toxic Assessments for ETO came due in 2014. So while those were being processed and they were doing those evaluations, you had this change in the IRIS value. and it basically was a huge disruptor and changed the landscape of the understanding of what's acceptable and what's not acceptable in the way of exposures and emissions. And in 2018, when that census tract data was issued, I mean, it put a spotlight directly on specific locations throughout the country where there was identified potentially unacceptable risk to ethylene oxide exposure. And as many of you may know, one of the very first areas was in the Willowbrook, Illinois area. And pretty shortly thereafter, that precipitated the first that I'm aware of litigation, toxic tort litigation associated with off-site ethylene oxide emissions and exposure. So what really happened and why there's been just so much activity in this area in the last few years is that once these two releases occurred, and I would mention that none of this is a change in the law or the rules. It is a change in the science evaluation and essentially a change in guidance to a certain degree. And the air toxic assessment is not even really guidance, it's just information about where there may be problem areas. But collectively what this did is it put great pressure on EPA, but really more fundamentally, it's fallen upon states to take this new information and decide what to do with it. I think many of you know that EPA's processes for taking information like this and converting it into rule changes is incredibly lengthy, subject to oftentimes multiple lawsuits and appeals. And we'll talk a little bit, but it is likely that that's going to go on for years. And to a large extent, and rightfully so, states can't wait that long. They have to make decisions about what to do. I'm going to go past this. This is just more in the timeline, but I would note that the very first focus by EPA to actually move toward adopting rule changes were under the miscellaneous organic manufacturing sector, and there have been proposed and final rules out there, but there are issues that EPA has not addressed with that yet, and my guess is that it's going to take a while for those issues to be resolved to determine whether EPA is going to make any changes to that final rule, and then ultimately whatever they decide is likely going to be appealed. On the sterilizer side, it's a little bit farther behind, but as Pilar alluded to, there has been the surveys that are going out now. They're trying to collect more information, all with the focus of trying to determine how to modify the rules in light of the new IRIS numbers. All right, so this is just I think a way of showing the likely delays and time frame that you're going to see action. This is all really out of EPA's mouth as to their proposed schedule, and I think we all know that schedules come and go. So, it's very possible from EPA's side, it could be a lengthy process, although I would say, in my opinion, once they start putting out new rules, and once those rules go through the, appeal and challenge process, and the science of what they're doing is affirmed, then it will probably be easier to complete the process for other industrial sectors. So what are the states doing? This is actually something that I have been involved with the client that I described earlier, because they have a national distribution system. They need to understand every state and where they're at on this. And essentially, I'm not going to get into state by state or anything, but there's different sort of categories of how states are dealing with this. Some are just doing nothing for the time being, and they're continuing to follow the adopted NESHAP, since that is federal law, and they have to comply. They can be no less stringent than that. Other states are taking a different approach. They may be doing some of their own risk evaluations. They may be phasing in some changes to new sources, but not to existing sources. But they're not necessarily adopting outright the new IRIS numbers and then integrating that into their permitting requirements and their control requirements. There's a mention here about warehouses. This has been really a new branch in the regulatory process that's going on here that has arisen because of the fact of the ethylene oxide off-gassing over time from sterilization to shipping and to storage in warehouses and distribution centers. And so what they're now finding is that off-gassing can produce as much or more emissions than what you see in a sterilizing facility where you have a contained, controlled sterilizing unit. So that's a whole new area, and I don't know, where that's going to go, but I believe EPA currently is looking at it, but I'm not aware of any indication that they believe that they should regulate warehouses under the Clean Air Act, or whether they have the authority to. But certainly some states are now looking at that, including Illinois and Georgia, I believe. So the most stringent states are actually taking the IRIS numbers and looking at specific facilities and trying to quantify through testing, and Dave Berkowitz will, I'm sure, get into this, the emissions, do stack testing if that's feasible and then that's representative, or some modifications thereof, and then actually do air modeling, inputting the new toxicity numbers and producing outcomes as to whether there are acceptable or unacceptable off-site exposure areas. And, this is a hugely difficult issue because of the fact that the numbers being generated through this process are so incredibly low, and in many cases it's been shown that they're lower than background. So how, once again, how do you deal with that from a regulatory perspective? All unresolved and currently actively debated issues. On the litigation side, as I mentioned, the fact that Willowbrook ended up as a identified census tract, and with the IRIS numbers that produced significant litigation, and then that in turn has spawned similar litigation, from my perspective, very similar to what we see with other types of toxic tort litigation, where the plaintiff side identifies a issue, identifies how to evaluate that issue, and then seeks to replicate it, across all potential locations that might have that issue. And the 2014 national assessment is basically tailor-made for that kind of concept, and that's in fact what we've seen, which is that areas identified by census tract are being actively pursued, litigations being filed, and I would add, in the new age of internet and whatnot, publicity, things like WebMD's reporting on all of this, I think is also accelerating the pace of litigation. Aside from the assessments, other aspects of I think from a litigation side of importance, EPA's Inspector General report, I believe is very an important report, because it's basically, the Inspector General is basically telling EPA, you've got to move fast, you've got to accelerate your rulemaking process and deal with these issues now. The New Mexico litigation was novel. Certainly all states have the right in certain circumstances to pursue claims on behalf of the state and its natural resources. And in this case, New Mexico has used sort of a variation of that to actually go after a specific sterilizing company or facility. So I believe that is the end of my presentation, and I would be happy to answer questions later, but now I'd like to turn it over to David Berkowitz for further discussion.
Thank you, David. It's actually I'm gonna turn this over to Pilar.
My apologies.
Thank you,
Sorry
David.
about that, Pilar. Yeah.
No worries. Thank you, David, for that history and legal landscape on ethylene oxide. It has sure been a complicated issue for us. And now that you're aware of the history and current regulation of ethylene oxide, we can go over some case studies as they relate to the sterilization industry, some of which David mentioned in his timeline. When this all started back in 2018, we were working with several medical sterilizing facilities. But as these types of facilities are being addressed, we have seen that the attention has shifted to other sources of ethylene oxide. I can tell you that just in the past year, we've had at least 6 cases of ethylene oxide for chemical manufacturing facilities. And it has been a combination of permitting, compliance, and litigation work. So ethylene oxide is used to clean and sterilize the medical equipment, and it's kind of an interesting process because they place the medical devices in the chambers, and then they introduce ethylene oxide, and it penetrates the packaging and sterilizes the equipment. There are several key differences between the use of ethylene oxide in the sterilization industry and the chemical industry. One of them is that for some medical devices, like those made out of plastic, using ethylene oxide to sterilize them is the only FDA-approved technology. And FDA has made it known and clear that, especially right now during COVID, we still need some of these plants to sterilize the equipment as they are concerned about a shortage of medical supplies, during the pandemic. And as David mentioned, EPA is looking into, working with the rules to reduce emissions. But while they haven't issued those rules yet, they're also working closely with state and local air agencies to see if there are anything else or more immediate emissions reductions need to be taken for several facilities. So what we've been seeing, and so what this means is that facilities are required to perform air dispersion modeling of their ethylene oxide emissions and compare these results to the stringent IR standards, which makes compliance difficult. So a lot of it has been happening in Illinois, and they passed 2 bills that have more stringent requirements than the federal standards. So the first one was a bill for sterilization facilities, and they're required to capture 100% of all fugitive ethylene oxide emissions and reduce ethylene oxide emissions from each exhaust point by at least 99.9 or 0.2 parts per million. The bill also requires an initial and an annual emissions test. And if the facility fails to test, then they're required to immediately cease operations. And then they also passed a bill for non-sterilization facilities, and they're required to get a permit and a site-specific limit on ethylene oxide emissions. And dispersion modeling has also been required for most of these facilities to demonstrate compliance with the IRA standards. So now going into Willowbrook, Illinois, which David mentioned, this was one of the first facilities that EPA took a look at. So this is kind of the same thing on the stories that the 2014 NADA report, which was updated in 2018, showed increased cancer risk from ethylene oxide emissions in the area. And this was one of Chicago's western suburbs, so there were a lot of residential areas next to the facility. So this graph right here is from an EPA risk assessment, and it's showing high cancer risk in the community, and that was even after implementation of controls, voluntary controls. And this is publicly available on EPA's website. So the facility faced over 700 lawsuits, and EPA even installed monitoring equipment, but they were showing elevated concentrations as well. So the Illinois EPA shut down the facility, and during that time, the new restrictions that we were talking about on the previous slide were passed, and they did reach an agreement to resume operations, but the company said that it was an unpredictable legislation and regulatory landscape, and so they just left their Willowbrook operations. So there has been a lot of movement in Georgia as well. They passed these two identical bills, and it requires facilities to report the spill or release of any amount of ethylene oxide within 24 hours, and to make the report publicly available on the EPD website. EPD also uploads anything related to ethylene oxide, any permit applications, modeling reports, compliance reports, and even enforcement actions. And Georgia EPD has a toxics program, so they have been requiring almost every facility with ethylene oxide emissions to model against the IRA standards. So this first case in Georgia is a facility located in Smyrna. Smyrna is a small city close to or in the Atlanta metro area. And again, the 2014 NADA report showed increased cancer risk, and the community was outraged. I am based out of Georgia and can tell you that there were protests all over the news against, use of ethylene oxide. And there were also commercials from law firms stating that if you were exposed to ethylene oxide in certain areas and were later diagnosed with certain cancers, that you may be entitled to monetary damages. The facility actually shut down voluntarily to implement voluntary measures to reduce emissions after they were contacted by the agency. But while they were closed, they received a letter from the county telling them to remain shut down pending a review of fire and building code. So since then, the company has been kind of back and forth with the county. They are currently operating as far as I know, but they continue to face backlash from the Smyrna community. So this one is related to what David was talking about, the warehouses, and that's why this particular case is interesting, because it is a warehouse, not a medical sterilizing facility. So WebMD in Georgia Health News report detailed the cancer risk around this community, and they had a consent order to estimate and determine fugitive emissions, and the samples came back higher than anticipated. I think they were estimating about 3 tons per year from ethylene oxide just off-gassing from the medical products here. And like David said, these products were just stored at this warehouse after they were sterilized and prior to shipment. So the EPD did charge the company with a violation for operating without an air quality permit, and they also had some special stipulations that prevented the company from putting any supplies sterilized with ethylene oxide for a period of time to reduce their emissions, and requested that they monitor air at residential areas and also at schools near the distribution center. So they did install controls that was required by Georgia APD, and I know that they resumed operations in 2020, but since then I have seen Georgia APD posting things about other distribution centers in the area, and, you know, like David said, there are also other states looking at distribution centers. So this one was also kind of one of the first ones, and it was interesting because the facility just chose to not work with ethylene oxide anymore. The agency performed the modeling, and, you know, they were seeing that there were issues with the state ambient ethylene oxide standards, and they actually did ambient monitoring at the site, but at the time the detection levels were still above the health protective level, so they just agreed to not continue using ethylene oxide. So these case studies are just examples of what's happened with the medical sterilization industry, but like I said, chemical companies that use ethylene oxide as a reagent to make their products are also getting a lot of attention from local agencies in the EPA, even if you may think all of the ethylene oxide gets consumed in the reactor. Some have been required to submit permit applications and air dispersion modeling reports and determine compliance with the IRS standards. So how to avoid some of these issues? I think, you know, most importantly, you want to be prepared and proactive so that you're not caught off guard. And these are several steps that you can take now to prevent future problems. But I do want to say that every facility is different and every agency addresses ethylene oxide differently. So these are general steps, but in reality, it's going to be on a case-by-case basis. I would not suggest the same approach for every facility. But the first thing is to review your ethylene oxide emissions. And this means to make sure that you're accounting for all your sources of ethylene oxide. You know, obviously you want to make sure you're in compliance with the current federal and state regulations. And in most cases, stack testing is been needed because the theoretical formulas that we use are often too high and conservative. For some facilities, they have had to place a more enhanced leak detection and repair program just to reduce ethylene oxide emissions. You also never know what you'll need to change based on updated regulations. So some agencies that I have seen are requiring continuous emissions monitoring. So keeping up to date with the regulatory developments, and if you can get involved in the regulatory process, if possible, so that you can have an input on how compliance will be determined for your facility. For example, I read a proposed bill that was requiring ambient monitoring, which has its special challenges, and I'm sure David's going to talk about. And it said, get to know your neighbors. Are there any lawsuits or environmental groups around the facility? Another key thing to look at is your state agency taking actions on other ethylene oxide facilities. That usually means that you may be next on that sense. And lastly, to partner with experts to help you navigate all these issues. EO issues are very complicated. We have had to come up with very creative ways of reducing ethylene oxide emissions and refining ethylene oxide emissions. And we have had also to understand some of the technological limitations like EO detection levels. There are a lot of pieces to manage for this type of projects. Usually it includes stack testing, you know, enhancing the leak detection and repair, finding emissions reductions, and complying with all regulatory requirements. So I think it is important that every member of the team is communicating what is needed and working together towards the same goal. These projects usually take a lot of time, and I think knowing where to focus your efforts is key to finding a solution. I guess an example of this is that a lot of times people think that they have to focus on their stack emissions, and maybe in some cases you should be focusing on your fugitive component leaks if they are your main drivers. And now David is going to go over some of the steps that facilities are taking when it comes to measurements.
Thank you, Pilar. Appreciate you going through all that portion, kind of giving everybody some things to think about. What I'm going to cover today is kind of what we've kind of progressed when we've been engaged by medical device manufacturer, sterilization company. We've kind of gone through a general process of evaluating their impact in surrounding areas. And kind of step one here is just evaluating the concentrations that are going to be in the surrounding area, residential areas. And this is really done through emissions testing and dispersion modeling. And really, if you've got an active agency, they've already done that because the emission testing results are available, and all the other data is available, and they can kind of walk through and run an air mod model and figure out what impact is theoretically in the surrounding area. So, one of the things that we can do is assist on that front and just kind of get everybody to kind of do a temperature check and figure out where they stand relative to these IRIS numbers, or where the surrounding areas potential exposure is relative to these IRIS numbers. And then kind of step two is, well, now I have these numbers, and we kind of have an idea of what the impact is or theoretically is surrounding the facility in the residential areas. But what is it really? So there's a number of ways to do that through ambient monitoring. Some of them include discrete sample collection. Canisters are typically used for this. EPA uses this, the states use it. They can be placed at areas, near the facility and the surrounding areas in residential areas. And then whenever you're doing a test like this, you'll want to also evaluate background areas. Somewhere these would include places that would not be suspect to be influenced by industrial sources of ethylene oxide, because it's been proven that ethylene oxide there's a background levels of ethylene oxide in all areas, and that makes it really difficult to kind of understand impact, especially when you're doing short-term monitoring events. Another way to do this would be through real-time monitoring. Tools that we've used are a mobile laboratory to be able to kind of move around and collect a lot of data near the facility and the surrounding areas. This allows pretty rapid coverage of a lot of different areas. The downside of something like that would be that it would be one moment in time, whereas if you were collecting discrete samples, you could do that over different times, dates, weather conditions. And then one other thing that we've been pulled in is in instances where state agencies have requested or required facilities to upgrade their emission control equipment. After we've kind of gone through steps 1 and steps 2, and facilities have voluntarily done this as well, upgraded their emission control units. So they basically reconfigure to their emission points to a single emission point, and then have finishing or polishing controls in the form of dry bed scrubbers. Also putting capture control on fugitive emissions. We're putting kind of a negative pressure on their facilities so that all the air within the facilities are being routed to a control device such as a dry bed scrubber. So we've been in those situations where we've kind of helped that and done some testing to assist that process. And what I'm going to do next is just discuss some of the tools that we use to do the measurements along the way. These tools can be used, FTIR can be used for both ambient monitoring and stack monitoring. There are optically enhanced FTIRs that are able to measure down to the single-digit ppbs, maybe even down to a half ppb, depending on the matrix of the complexity of the stream. These can also be standard FTIRs can also be employed, which would have a detection limit in the ppm range. They might be useful for measuring inlets to control devices, and then the outlet to control device would be, you would use a lower level detection. And then the next two I kind of mentioned, canisters for ambient monitoring could also be collected in areas within facilities to understand concentrations that can go down to as low as 20 parts per trillion. And then our mobile laboratory is a proton transfer time-of-flight mass spectrometer that's capable of measuring as low as 70 parts per trillion with a data point every second. It also has a weather station on it, so we could park in a certain area, evaluate wind direction, kind of upwind, downwind in real time, and move just to understand concentrations in different areas and influences of different potential sources of ethylene oxide. So next I'm just going to go through a case study where we were engaged by a multi-office, multi-location medical device manufacturer who was having some issues with the state agency requiring them to upgrade their control equipment based on modeling of their existing control devices and configuration and production. And so they were in the process of doing that and then putting an enclosure, total enclosure of their system to control fugitive emissions. We've been engaged on the front end of that, collecting data for them to understand fence line concentrations and community concentrations. And through the process of their upgrade, we were helping them negotiate, or not negotiate, but just move through the process of working with the state agency to get to the point where they would minimize their downtime. So once they finished their project of upgrading their emission control equipment, we were brought in and we did some capture efficiency testing to make sure that the facility was under negative pressure and all of the potential fugitive emissions were being routed to a control device. Then with the new system, and once that was tested and validated, we came in and we did some stack testing to understand, what the emissions were coming from their stack. At that point, we had that data plugged that into a model to understand the emissions, impact on the surrounding community, and the state additionally required them to install a continuous emission monitoring system, maintain that, and produce data on an ongoing basis for submittal to the agency. So we assisted with the installation and operation and maintenance of that device. Once the modeling had been completed, the state also required them to have an ongoing ambient monitoring program. So we went through the process of working with the states to evaluate sampling locations, prepare a sample plan, have that approved, and then launch an ongoing ambient monitoring plan based on all the information that we had put together and worked with the agency on. Our internal laboratory, Enthalpy Analytical in Durham, had been out in front of ethylene oxide measurements for a number of years, working on lowering the concentrations, the detection limit of ethylene oxide in canisters, also eliminating interferences, as there's many known interferences at low concentrations. So we engaged them. They provided the clean canisters, calibrated flow controllers, and then sample analysis. And they're supporting ongoing program where we kind of keep this thing going, and the facility stays in compliance with that particular requirement. So throughout this whole thing, we were able to engage multiple lines of our business and simplify the program for our customer, providing real-time ambient measurements and ambient fence line measurements, pre and post, laboratory services and source testing, and compliance services in the form of permitting and dispersion modeling, and ongoing operation and installation of a continuous emission monitoring system. So, pretty full turnkey source of services to support them. So just to recap the tools that we bring to the table, we can do source testing, for ethylene oxide down to about 2 parts per billion, even lower depending on the complexity of the gas stream that we'd be measuring. As far as troubleshooting, we can help with initial startup and engineering of reconfigured emission control systems, as well as ongoing compliance testing. We can do optimization studies on absorbers, scrubbers, and oxidizers to help facilities, really optimize their equipment and get their emissions as low as they're able to with their existing configuration. We can come in and do SEMS installations. We can operate them ongoing and provide the maintenance, as well as periodic quality assurance audits. The SEMS that we've put in place are optically enhanced FTIR, or Fourier transform infrared spectroscopy. Trademark is Star Boost. These systems have been in operation nonstop for going on 2 years at facilities. Very rugged, able to report in the single-digit ppb range with very little maintenance, ongoing maintenance and repair. And then we provide ambient measurements in the form of mobile PTR time of flight mass spectrometry. we've installed SEMS, or continuous monitoring systems, not really emission systems, but plant-wide. So area monitoring within facilities using optically enhanced FTIR, able to measure up to 20 channels per system with a data point every 10 seconds, to provide some real good clarity on facility-wide concentrations in the areas, and also EPA TO15 sample collection and analysis, providing some of the lowest detection limits in the industry. And that concludes what I've got to share today. And with that, I'm going to turn it back over to Jessica to, I guess, circle back to question and answer.
Yes, thank you, David. And I want to thank all three of you for a wonderful presentation this afternoon. We did get quite a few questions in during the event. I know we will not get a chance to answer all of them, so somebody will follow up with you if you did submit a question that we do not get to during the live event. And if you have questions as over the next 10 minutes, 9 or 10 minutes or so, please keep submitting them, because don't worry, they will be addressed. But Pilar, I think I'm going to start with you. Given the strict standards, have you been able to successfully demonstrate compliance through air dispersion modeling?
Hi, Jessica. It has been a process. So, we started modeling in 2018, and it was a learning curve for everyone, the agency, us as modelers, and just getting the facility to a place where it was showing compliance. But we have been able to do it both for sterilizing facilities and the chemical industry. And, almost every case we've dealt with this year, we have been able to get to the low and strict standards.
What do you think has been, I know you mentioned some challenges, what do you think the biggest challenge has been since 2018?
Well, I think, and probably they're going to want to chime in on this one, but there's been a lot of different challenges. One, having detection levels above the acceptable standards, that's a challenge for compliance. So they kind of moved on to modeling, and when we do modeling, there are some challenges with the model itself as being too conservative for fugitive emissions, and a lot of the facilities have a lot of fugitive emissions. So it's been just a catch-up of technology to this new, very strict standards, and catch up on the way that we think about ethylene oxide emissions and how we go about finding reductions or refinements in the calculations.
Which definitely makes sense. David, did you want to chime in too with my follow-up question there?
Sure. This is David Nunn. I'll follow up, I think, on the legal regulatory side. And I think a really challenge, particularly for companies that are in multiple states and jurisdictions, is just understanding what their compliance obligations are. And in most cases, right now, those obligations may not be exactly spelled out in the rules, or they may fall within discretionary permitting or other types of catch-all authorities. And in many cases, such as switching from a NESHAP based just on destruction efficiency to things like offsite modeling, the agencies are trying to figure that out as they go as well. So, that's all kind of shifting targets, so to speak. And I think that at least my client, they want to do the right thing. They want to get to a point that's safe for their employees, for their neighbors, et cetera. And they want some consistency, and it's just, I'm not sure we're there yet in the regulatory world.
I appreciate you going into some more detail there, David. I'm sure that our attendees would love hearing about the regulatory side as well as your experience with it. David Berkowitz, I'm going to send this next question over to you as we only have about 5 more minutes left before we've got to wrap up today's event. What are some of the challenges you have seen with EO background concentrations?
Thanks, Jessica. Yeah, that has been a real challenge. David Nunn, I think, touched on it, and as well as Pilar. There are, known concentrations of background throughout our country, and some of the studies have been done in some, urban areas near sterilization facilities and some other areas. And we've been engaged by a number of customers to kind of understand concentrations or potential emissions from other known sources of emissions, such as, cigarette smoke and, airports or other combustion devices, vehicles. And so, it becomes a real challenge to understand, what the concentration surrounding a facility, whose emissions those are, who's responsible for those concentrations. And it's just a matter of really collecting a lot of data to understand concentrations over different time, different weather conditions, different modes of operation, different times during the day of higher traffic. So it's a real challenge, and the EPA is doing their own research to really understand background concentrations and how they what the true impacts are and the sources.
Thank you. I appreciate that. Pilar or David Nunn, did you want to add anything to his comments, or should I move right along to the next question?
Well, this is David Nunn. I mean, I would just say that, from a regulatory perspective, it obviously poses real challenges when your backgrounds may already be posing risk that is deemed unacceptable, and now you've got a potential source within that zone, and you're trying to figure out, well, what's acceptable and what's not. I mean, there's not much margin to work from, is the bottom line. So I'll leave it at that.
Thank you. And I think I'm going to stick with you for probably what's going to be our last question. Do you think the EPA will reconsider their current IRIS standard based on TCEQ and other studies?
I don't really know. I don't have any insight into that. I think that the history of these kind of situations is that, science evolves, understanding evolves, and there's always some level of debate about, how do you conduct these studies and models and whatnot, risk assessments. But, typically, the government side or public sector side and where they fall on this typically prevails in large measure. And yet I think the process allows people that have concerns to articulate those concerns, and it gives the government and EPA or whatnot some insights of what they need to consider as they apply the new science. And so it may be that the IRIS numbers stay in place, but there is some, regulatory changes made to potentially allow this to not be a situation of impossibility of performance, so to speak. So, I would also say history tells us that when we're using a chemical that ultimately, the majority of people may think is dangerous to the point of it shouldn't be used, our innovation will find solutions to move on from that chemical. And sometimes we're surprised, like with ethylene oxide here. I mean, it's so heavily dependent upon in the healthcare sector. But that's not to say, and it won't happen immediately, but it's not to say there won't be other solutions that arise and start, eating away at the reliance on ethylene oxide.
Well, I just want to say again that we really appreciate the expertise that was presented this afternoon from David, Pilar, and then David as well. I really enjoyed listening to today's presentation. Thank you to the attendees who submitted questions and who were able to join us live, and thank you again to those who will watch this on demand. This presentation will be archived within the next 30 to 60 minutes, so you will have the opportunity to come back and review the presentation at your leisure. So once again, thank you to the teams at Montrose and Eastman Smith for putting together this presentation today. And I hope everybody has a wonderful rest of the day. And this concludes today's webinar. Thank you.